Hi, everyone, and welcome to the Blockdaemon Podcast. Today, we'll be talking about the future of proof of stake. We have an amazing panel of experts to join the discussion about the future of staking, the staking landscape, innovations, and challenges in the space. Joining the discussion is Mao Hu, ZeroCap's head of engineering, Nathan Lenga, innovation lead at ZeroCap, and Freddie Svanziger, Ethereum ecosystem lead here at Blockdaemon. So let's dive right in. As we discuss the future of proof of stake, we must first consider staking's position in the wider digital asset regulatory framework, specifically how proof of stake will align with existing and future regulations. Nathan, for yourself to kick off, could you discuss the differences or the impact that regulatory frameworks will have in the future and are having at the moment between countries and their impact on staking activities, specifically maybe touching on the Australian side of the world where ZeroCap is based?
Yeah, for sure. So there's always going to be discrepancies between regulations in different countries, and that always sort of creates this sort of arbitrage opportunity between where you can set up shop and run all of the systems through. In Australia, following the SEC and I guess the crackdowns that Coinbase is facing and Kraken faced, there's this push to sort of follow it with our sort of, head of regulations, or the big body in Australia called ASIC. And the way that ASIC's looking at it currently is very much so where if there's assets being pulled together to set up a node, that is illegal. And hence it kind of gets to this point of you have to be really clear about how a transaction is going onto the chain and then being staked to ensure that you're not performing that illegal task. In I guess in regards to Ethereum and proof of stake, it's pretty easy to just get 32 ETH and then put it together. But for other proof of stake systems, especially if it's something like DPoS, or for Polkadot, where you have to bond it all, there's an element of it's being pushed together into a pool and then being staked. So in those situations, ASIC is not going to be happy. So we've got to be really careful. Whereas in other countries where the environment is a bit different, that's fine, and that's not really viewed as being different from any other sort of type category of staking. So it's just about trading carefully in terms of actually mapping out on chain what goes on, and then sort of having the ammunition of that argument in the back pocket in case ZeroCap or another entity in Australia gets questioned by ASIC. But yeah, so there's always going to be a difference, and it's really about what you set up and working with that main regulator. Yeah.
For yourself, Mao, I want to touch on the question of how decentralized will staking be in the future. Obviously, decentralization is a core aspect of cryptocurrencies. In the context of staking, I'd like to explore the balance between decentralization and efficiency. Specifically, maybe talk about some of the trade-offs between decentralization and efficiency in the context of proof of stake systems. And I suppose discuss maybe your opinion, what is the ideal level of decentralization to achieve a balance between security, performance, and inclusivity as we look at proof of stake in the future?
Yeah, well, the Ethereum implementation of proof of stake is already a kind of really interesting and really difficult and impactful step forward in hopefully a more decentralized paradigm. Because if you look at like successful, production grade layer one, battle tested proof of stake systems, we all started with delegated proof of stake, and that called family of systems between EOS and then like the Steemit and various systems for that. And they worked like in theory, but then again, in theory, there's not really they were obviously really interesting innovations, but there wasn't as much room for error because really they were just implementing practical Byzantine fault tolerance again with kind of additional incentive mechanism on top. And so the whole idea of being able for like everyone, and not exactly everyone, because there is a fairly high threshold, but almost everyone being able to stake their ETH directly, and also that it actually being deployed into production, the whole community actually moving over, nothing happening like the DAO fiasco in 2016 or the parity hack, nothing like that happening is absolutely amazing. And it's a real testament to the engineering and the technical and academic acumen of the Ethereum team. Now, that being said, whether that'll actually lead to more decentralization is yet to be seen. Again, it's a really good step in the right direction. But on the flip side, it's still a fairly high minimum. There's still a fairly high level of, of technical sophistication required to stake successfully, which is why companies like Blockdaemon exist. There's still the problem that ultimately people who are staking are earning interest and not like a fairly high level of interest on their earnings, which means that over a long run, you would expect capital to reaccumulate and those that already have capital. So there's still kind of a number of problems with how the system is being set up. So I think everyone would love to see complete decentralization, or maybe some kind of weighted decentralization based on how stable internet is and based on how altruistic and well versed in the protocol people are across the distribution of human beings or whatever systems across the world. In reality, I think, well, I mean, I guess we'll have to see.
Building on the topic of decentralization, Freddie, I'd like to touch on which parts of the network stack can and should be decentralized, specifically taking a closer look at governance, incentives, validator selection. Ethereum famously has no on-chain governance, whereas you have other proof of stake protocols where there are actively running governance. We see that on Cosmos, we see that on Cardano. Given the fact of Ethereum's success and its governance model, has Ethereum's governance model got it right? And is that going to be the default going forward, do you think? Or do you see more role of decentralized autonomous organizations in governing staking protocols going forward? How are you looking at governance going forward into the future for proof of stake cryptocurrencies?
Right. I think this is a very interesting question. I don't think Ethereum necessarily got the governance perspective right, even though I am no fan of on-chain governance. So I think there's some merit to the off-chain governance that Ethereum has. Now, whether that's a consequence or a reason for success that Ethereum enjoys right now, I guess nobody knows, right? What I found interesting is, number one, if you want to achieve decentralization, you have to achieve it on many, many different levels. It could be client diversity, could be geography, could be, cloud providers versus bare metal hosting versus on-prem. It could be, the minimum requirement of capital would be something. But particularly with regards to governance, I think there's the interesting bit on Ethereum is that there's also some levels of DAO governance. Like if you think about Lido, liquid staking protocol controlling, I think about 33% of the total ETH staked right now. This is governed by a DAO with all its benefits and drawbacks potentially. So far, Lido has been very successful and seems to be let's say a force of good in the ecosystem, I would say. But there has been some criticism about that and concerns about risk of governance attacks on Lido because they control such a big stake. And then there's others like Rocket Pool and others that sort of try to bring other innovations on that. So I think actually in the end, it'll always going to be a mix between different governance models. And I think generally I'm a fan of heterogeneous systems, basically, because whenever you have a monoculture of anything in biology or in this kind of systems, it's more susceptible for attack or abuse or something. So to encourage overall resilience, I think a diversity of approaches, including in governance, I think is the best way forward.
And you touched on diversity there. Mau, maybe talk around the decentralization on a hardware front, from the hardware perspective, and maybe discuss the feasibility and desirability of complete decentralization in hardware infrastructure for proof of stake networks and the potential impact on network resilience, energy efficiency, and attack resistance from an infrastructure perspective.
Yeah, well, I mean, I think it's something you want to target. I think you see not exactly a terrible precedent set in the Bitcoin mining space, where you have a few large ASIC manufacturers. And also, if you want to do Bitcoin mining, you don't use ASIC. You're like, the game's over for you a long, long time ago. It has its ASIC or nothing for a long time now. I mean, I wouldn't say that companies like Bitmain have been bad stewards of the network, but certainly it's created different kind of incentive mechanisms that were unpredictable at the time. And going back to the earlier point, it led to over 50% concentration in China, and now over 50% concentration in the United States. So there's still, a number of thus far mostly theoretical, but certainly possible attacks that open up from this kind of concentration. And so, and then now in theory, in Ethereum proof of stake, there's not quite the same requirement. Now, I guess there would be the case that certain classes of processors or systems would be more resilient, would have more theoretical uptime, whether it's like some kind of distributed system. We all saw that if you look at the so-called, I guess, classical Silicon Valley bubble, the dot-com bubble, and you look at how server architecture kind of evolved over time, where it had like these big old mainframes, and then Google was the first one to come up with, well, like if we have this massive like cabinet that's air conditioned, why don't we just stuff it full of really cheap commercial grade servers, and then just if they fail, they fail because they're so cheap, it doesn't really matter, and we'll just run a distributed system over instead. That'll be why we have high uptime, and it's basically how everyone's running their servers now. So it's entirely possible that we're kind of like collapse back in that kind of paradigm where there's some kind of global optima in terms of cost efficiency, and then that'll just reconcentrate power back into maybe a few large chip manufacturers or a few large computer hardware manufacturers. So the jury's still out there. It's kind of hard to say whether the way things are set up, it might actually lead to more decentralization in hardware. In theory, having any kind of rigid protocol is always going to lead to some kind of optima as people kind of figure it out. Market forces are pretty intelligent over time. Again, so I guess we'll have to see. But again, it's another interesting step in the right direction.
And then, having covered various aspects of decentralization, let's move on then maybe to the innovations and some of the potential advantages that these new innovations could bring to the staking space. Specifically, Freddie, some of the innovations that come to mind for staking recently are decentralized validator services, EigenLayer. What is your perspective of these new innovations when it comes to staking, including decentralized validator services, and maybe what are the potential benefits and also potential challenges that these innovations could bring to the overall security and scalability of proof of stake networks?
Right, absolutely. So obviously we're very excited about all these innovations, and that's part of the reason why I'm in this space, because there's just so much going on, and the speed of innovation is so high. So with regards to some of the things that you mentioned, distributed validator technology, or DVT in short, obviously is another step forward in the decentralization, as we talked about earlier, as it would basically decentralize the single validator key to a group of people, basically, whoever that might be. And there's obviously different approaches by SSV and OBOL network and others. So that would eliminate one single point of failure. But like you alluded to, this might be a step forward, but it also comes with its own risks. Because if you then rely on, for example, a single implementation of DVT, and that would have a critical bug or something, then obviously that would have bad consequences if everyone would run it. Or like the peer-to-peer gossiping network between the communication between the participants of a DVT committee could also be faulty or something like that. So again, I would say that, coming back to my earlier statement, is that the more different approaches we have and live in the system, the more resilient it is, because it avoids central points of failure. And as with EigenLayer, we're very excited about that new paradigm as well, because it has the potential to increase the capital efficiency. Right now, those 32 ETH in Ethereum staking are locked and are earning their rewards of maybe 5% or so, but it's a lot of capital that's sitting there on the sidelines. And so it's just natural to try to, make it more productive. And we've seen this obviously with liquid staking, like I mentioned earlier, which gives you a receipt token that then you can, use in some other DeFi use cases, for example. And EigenLayer would have a different approach to reusing your 32 ETH collateral and securing additional protocols. Now, this would give the opportunity for our customers and any staker really to increase rewards with some additional risks, because there could be slashings on the new protocols as well. So that's something that we need to carefully balance, basically, and we'll certainly advise our customers in that regard. And then there might be effects that, if you participate in too many, then and get slashed everywhere, that could be bad. So I think this is very early days for these kinds of concepts to figure out. What really excites me most on EigenLayer is not so much the perspective for the stakers, but the level of innovation it can unlock on Ethereum that is pretty much similar to the Cosmos space with its app chains, right? So I think this is going to be another force that drives the multi-chain future. Along with all the layer 2s and the OP stack, and we've seen with base chain launching, obviously very exciting movements on the L2, all the ZK EVMs. There's going to be so many of different chains, whether that's layer 2 side chains, app chains, EigenLayer secured chains. I don't know. It's going to be tough to keep track, but again, it'll increase the diversity of the overall blockchain ecosystem, not so much the Ethereum stack itself, but the overall thing and the approaches. And so generally that's a good thing and exciting years ahead.
By the way, I just want to say that I think the EigenLayer is a terrible, terrible idea, because to me, it really is just a rerun of merge mining. I don't know if you guys remember that fiasco, but that was a great, people thought that was a great idea. It was like, oh, we'll just use SHA 256 and we'll support the same hashes from the Bitcoin network, and we'll quote unquote utilize the security from the Bitcoin network and the hash power. And what actually happened is you would have these like whales in the Bitcoin network that would make up like 99% of the hash power on the merge mine network, and they would just double spend attack it at their leisure. And I think ultimately, I don't think there's no free lunch when it comes to security. And so you think that you can try to build on this other network, but like Bitcoin, again, is another great example where people say that using ASICs, using SHA 256 is wasteful. But at the same time, like there's so much kind of institutional legacy hash power built into it. And it's such an esoteric space that if you really wanted to attack the Bitcoin network, you can't just turn on a bunch of supercomputers anymore. You have to buy a shitload of ASICs, and people are going to be, why is this CIA Inc. buying a ton of ASICs? What are they doing? And so it's very hard to sneak up and attack the Bitcoin network using the massive overhang of hash power these days. And so, trying to use EigenLayer to utilize the stake in the Ethereum network, I think is just kicking the can down the road for people trying to build their own security.
Advantages and drawbacks, definitely, Mau. And talking about the path forward for staking, Nathan, for yourself, we talk about in proof of work, we had minor extractable value, MEV, and now we have maximum extractable value, which is factually become more important post-merge. Could you talk to me about the relationship between MEV today and institutional staking, and suppose the role of MEV in proof of stake systems?
Yeah. I might reverse all of those questions just so it kind of flows a bit better in my head. But I think in any blockchain, and it's been said for many years now, that at the moment, MEV is just some fundamental value that's going to be there, right? It's the same way that there's extra, value in free markets. We have HFT firms, we have market makers who capture all this value, and that's their whole job, and they're regulated to do so. And it's very similar when you have so much financial instruments and vehicles being built in the DeFi space. There's going to be arbitrage opportunities, there'll be liquidations, there'll be extra value on chain for sandwich attacks. So there's heaps going on with MEV, and it's gotten to the point now that for a developer of a blockchain, of a layer 1, and eventually it'll be layer 2s, if consensus is sort of added into layer 2s when you have enshrined rollups. When building a new layer 1, if you don't consider MEV as a factor that will have some influence over the logical actors in the network, you're almost shooting yourself in the foot, right? Because it's this inevitability. And in that sense, the relationship between proof of stake and MEV, to many it seems sort of deleterious. To many view it as a some say it's a zero-sum game because someone wins, someone loses. Some say it's dead weight loss, which is also a fair take on what MEV is in proof of stake. But there are heaps of solutions that are sort of making them more harmonious together. And there's MEV burn, There's MEV share and split. Fundamentally, if you will, from our take, especially as market makers in the industry, that value has to be captured to have an efficient market. Otherwise, you're going to have people, making weird trades, different prices. There'll be no almost uniform prices or spot. This is options, derivatives, perpetuals, everything. So when you have MEV being actively captured, because that's the incentive, you're actually building more free and efficient markets. So the idea of getting rid of MEV in proof of stake doesn't make sense. But there's been heaps of innovations with like proposer builder separation, which is sort of centralized. Then you can say, well, then how about if we decentralize the builder role, which is even more challenging? And then there's all these layers of threshold encryption to ensure that it's not being cut in the middle of it. So when the proposer, I'm not really explaining it very well, but when the proposer selects the block that someone's built for them, hence it's competitive and decentralized, they don't really know anything about the block until they've chosen the most profitable one. But there's still ways around that. And hence, PBS is one of the big parts of the Ethereum roadmap. And quite clearly, if that innovation and that upgrade to the network comes after and will come after the merge, when proof of stake was actually established, it's pretty clear that that's where it's going. It has to be kick the can down the road issue that we'll solve eventually. But for institutions, the other question, it is also a gray area. Right. Last year, when Avi exploited mango markets, he was then arrested, which makes you think: is this front running? Right? MEV is capturing MEV front running, because again, if you go to the chain and you map it out for a regulator, it pretty much is, because you're looking at transactions before they're executed and deemed truth via consensus or social consensus, and then before that happens, you're saying, all right, this transaction is going to come in. I will pay this guy, this validator, a bit of money to put that transaction here, mine here, and the other one there, and then I sandwich them, right? So it's front running. But again, if you go back to the HFT firms, they're also doing the same thing in a different capacity. Not the exact same way. There's no memory pool for every financial transaction in the world, but it's this gray area where most agencies aren't even aware or aren't even equipped to solve the issue yet, and they're sort of cognizant that there exists this value on chain, but there's no solution to resolve it on from the perspective of regulators, and hence there is this grey area where if an institution or a family office or a hedge fund is staking and they've opted into using something like MEV Boost or some other client that allows you to extract MEV natively, it could be illegal. And it's a grey area that has to be solved at some point when there are fundamental regulations around crypto and staking, not just this inconsistency between country to country. Because again, that arbitrage will come up and everyone will move all their nodes to one country, and then you have the same issue as before with Bitcoin, being centralized in China or America, where all the nodes are being set up in one spot because they can capture the most value. It's simple, incentives and game theory in that sense.
Absolutely. And as we wrap up our discussion of MEV and staking, Mao, let's look ahead and explore the role of interoperability in the future of proof of stake. Specifically, we've seen examples around IBC. For Cosmos, we see side chains on certain proof of stake networks like Cardano, Algorand. What role can interoperability play in the future of proof of stake? And what are the most feasible paths for interoperability, in your opinion?
I think interoperability as a concept is very exciting. I mean, obviously, there's IBC. We had bridges a long time ago, is wrapping stuff and having a centralized counterparty putting a token to some other chain. Like Polkadot has been trying for years to really get like cross-chain smart contract constructions, going. So I think it's all really cool from a technical perspective. I'm not really sure that we need to reach this level of sophistication to just utilize capital across chains. I mean, if you really wanted to, if you're in two incompatible networks and you wanted to move your capital across and stake on the other chain, why can't you just sell your native token one chain, just buy the other token? I mean, it seems like there's a fairly simple mechanism that we can use without having to solve the really hard problem of like moving tokens over in a completely decentralized manner. That being said, probably is good. And the more decentralization, the more functionality allowed on chain, the better. It's not really a bad thing. I mean, I think I think it's going to be a really interesting technical development. I think we're going to see a lot of things that are unpredictable as these new capabilities show up. I don't necessarily think it's it's going to stop us from letting capital markets do whatever they're supposed to do.
And on that note, thank you very much, Nathan, Freddie, Mau, expert panelists, for joining us today in the future of proof of stake. It's been a fascinating and enlightening conversation. And to our listeners who are listening in, we hope you found this discussion as insightful as we did. So thank you very much.